Alright guys, we're going to go ahead and get started here now with 3.1. Before we get started, we got the warm-up, so go ahead and give this a shot. Pause the video before checking your answers, but go ahead and like I said, pause the video, go through the warm-up, and then hit play and we'll go over it. Alright, so number one, again what we're doing is we are just identifying again each of the following. So we want to do like vocab here. So we have points that lie in the same plane. So we want to use the definition for points that lie in the same plane. This one you should have had coplanar. Again, those would be points that lie in the same plane. Again, just knowing your definitions. Number two, two angles whose sum is 180. That would be supplementary. So again, number two, good old supplementary. Again, if they added up to 90, that would be complementary. So again, just note the difference. Number three, the intersection of two distinct intersecting lines. Okay, so these are, again, you're looking at the intersection. What type of intersection do you have of two lines? And that's just going to be a point. Again, the difference there, if they had, two planes that intersected, it's not, they don't always intersect in a point. If you had two planes that intersected, they'd intersect in a line, remember? So again, that's the two types of intersections that we've reviewed at this point. The intersection of two lines, which is a point, and the intersection of two planes, which intersects in a line. Alright, but this one's a point. Alright. Number four, a pair of adjacent angles whose non-common sides are opposite rays. So again, you want to, in this one you may want to just kind of draw it out if you don't see it. But we have adjacent angles whose non-common sides. So, you had an angle here. It becomes pretty simple once you see it. And then you have a second angle that's adjacent. So that means they share a side. We can say they share that side right there. But if it's non-common side forms an opposite ray, that means that this other ray that forms the angle is going to be an opposite ray. So it's going to form a line. Well, if you look now, we got these two angles. Well, these two angles are going to form a linear pair. So again, it's worded in a weird way, but if you draw the picture, you can see it. You got to know your vocab in order to see it. If you don't know how to draw what they're explaining, you're not going to see the picture, you won't get it right. Okay? So if you're stuck, draw pictures. If they're describing something, okay, the answer will kind of come to you. Alright, so anyway, that's our warm-up. Let's go ahead and talk about what we're going to be doing in Chapter 3. So Chapter 3 is going to kind of build on what we did in Chapter 2. Honestly, it's building on everything we've done at this point, but Chapter 2 we kind of started talking about proofs. So we're going to start proving things in Chapter 3, and we'll kind of follow that trend in a way throughout the year, but we're going to really be talking a lot now about postulates and theorems as well as definitions. Again, a definition is just a rule based off of a definition. A postulate is a given truth, something that we don't have to prove, and then we have our theorems, which are things that we must prove before we can use them. So those are going to be our three things. I'm going to list it here. You get your definitions, you have your postulates, and you have your theorems. So when we get to the theorems, just as a reminder, these are what we must prove. So if we're doing a proof of something, it's going to be a proof of a theorem. Postulates are given truths. Definitions are definitions. They're rules. So we don't need to prove those, but we do need to prove theorems. Okay, and sometimes we'll apply theorems to prove other specific concepts. So anyway, the objectives before we kind of get to a proof, we have to understand certain key phrases and words. So the definitions we need to know in this section. I'll try to highlight them as we go. You got to identify parallel, perpendicular, and skewed lines. So we're going to kind of start. We're not going to start with proofs. We're going to start by learning these new concepts in Chapter 3, and as we move forward, you're going to see us do more and more proofs. And again, the next thing we're going to have to be identify angles. formed by two lines and a transversal. So you're going to need to know what a transversal means as well. Okay? So those are the key phrases you need to make sure you understand. I'm sure you've heard some of them before, maybe not all of them, but definitely some of them, which would help. Okay, so there's a lot of concepts on this page, and it's kind of a tricky looking picture, so I'll kind of walk you through it as we go. But parallel lines, you're used to, in algebra, seeing parallel lines like, oh, got a line and another line that's parallel. Okay, well, these are parallel, obviously. I mean, as best they can. They look parallel, right? I can label them parallel. That's a little geometry symbol here. That little geometry symbol means parallel. Just so you know. Okay, the little arrows on the line. It's like an extra set of arrows. But anyway, if you look at the definition, parallel lines are coplanar lines, okay, and do not intersect. So coplanar means they're on the same plane. So if I drew these two lines, see how they're on a plane? Okay, but again, you look at the figure, you see they're giving you examples. AB is parallel to EF. Well, AB is right there, and EF is on the same plane. When I say the same plane, we're talking about that top portion of this cube, but they're on the same face, that top face. A face is the 2D image, or 2D side, A, E, F, B. It's both on. They're both of them. We're going to be on that plane. So some other ones you can look at. You can look at EG and FH. If you look at EG, EG is that vertical line right here. FH is another vertical line. And you see how they're both on the same plane, this front face? Okay, they're coplanar. And the key is they have to be coplanar and not touch. So those are the two key phrases on that. Coplanar and do not intersect. Because I want to jump up over here to skew lines while I'm at it. Skew lines are like parallel lines, they're just not coplanar. They still don't touch though. So again, they're not coplanar. That's the biggest difference. Okay, so they don't lie on the same plane. Skew lines are not parallel. Okay, that's parallel, skew are different things. They do not intersect though. So they have in common the fact that they don't touch, they just don't lie on the same plane. So AB and EG. So AB, it's on, oops, that's not even close. Here we go. So we have AB, which is this guy right here. Okay, and then you have EG. EG is not on the same plane. See how it's going up and down. Okay, and the AB is going left and right, but they're never going to touch. If they're going to touch, it would happen right in here where it crossed, where EG crossed that top plane. But they're not touching, so they're not going to ever touch, which means they're either parallel or skew. Well, because they're on different planes, they're not coplanar, then they're skew. Okay, now if they touch, then they're not skew or parallel, I guess, at that point, right? That's the one thing they have in common, is they're not going to touch. So if lines don't touch, they are either parallel or skew, and that has to do with the fact, are they coplanar or not? Okay, so let's again, this is a good little picture to draw so you can see it, because sometimes, just the definitions are kind of hard to understand by themselves. But here we go. Now we got perpendicular lines. And again, this is an important way to recognize them. We're going to use this a lot. This is a symbol for perpendicular. Okay, perpendicular lines, they intersect at a 90-degree angle. So again, you have that little red square that represents it's a right angle or a 90-degree angle. So as long as two lines are forming that, you're going to have perpendicular lines. So AB and AE. So we got AB, AE, they got this right angle where they intersect. Same thing with EG and GH. EG, you got EG, GH, and you got that right angle in there. Okay. Finally, parallel planes. Now, plane, again, we're talking about the entire plane. Like this is a plane, and any plane that doesn't intersect ever is going to be a parallel plane. So like the top and bottom of this cube will never touch. They're parallel. So they call that ABE. See how they're using 3 points on the plane to label it? Well, that's parallel to CDG. C, did they call that wrong? CDG, they must have called that wrong because well, as you can see, there's no D here. But let's assume that was D. So C, D, G. I think that's something that they meant. It almost looked like that was like cut off there. You see the little white in the background? Looks like it was already changed. I don't know. But you know, the C, D, G, let's just call that point G. Or D, I'm sorry. Okay, so then that matches. I'll keep it there. Alright, but those are parallel planes, as you can see. They're never going to touch. They're both horizontal. And then obviously you can do the left side and the right side, like this side and this side. Those are parallel planes as well. And the front and the back are parallel planes. Alright, so you want to know what those mean. So that's hopefully a good explanation of those. Key definition phrases, obviously. It's the first thing we learned in 3.1. Okay. So, helpful hint, again, as we just move forward. So again, segments or rays are parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. So in other words, we need to make sure we understand what relationship we have, because those are the three concepts we're really talking about: parallel lines, skew lines, or if they do happen to touch, we want to see are they perpendicular or not. These are all our options, so we want to make sure we understand each one of them. Alright, so example 1, we can try to draw this picture. Again, what you really need to do is just sketch the picture. Obviously, I don't care about drawing the actual cards. But we're going to take a look at this. You can pause it so you can get it written. Again, if I do a note check on this, I want to see the pictures. Don't just write answers. If you write answers, then I just won't give you credit. That's fine. Okay. Example 1, again, we're going to identify each of the following. So we want to find a pair of parallel segments. And again, there's a ton of them. And again, the key on this is what I was telling you before, is you got these little arrows. Well, these arrows are telling you that we have parallel lines. So I can tell you right off the bat that these two lines are parallel. I can also say that these two lines are parallel. And again, see how you label this? Because these arrows are going in the same direction, and there are two arrows, I know that any line that has two arrows on it is going to be parallel, as long as it's going in the same direction as well. So again, I got these 4 lines here. I could pick any 2 of them. They just said a pair. Pair means 2. So I'm going to go ahead and I'll pick the one with only 1 arrows on it, the one on top. It's the first one I found. So I'm going to say that NK, and again, they said parallel segments. So I'm going to say NK with the segment notation on top, not a line, it's a segment, is parallel to ML. Again, as I'm doing this, I'm showing you how we label parallel segments. We use this double line segment to represent it. Okay. Now, again, you could also just call this NK and segment ML. That's fine, because that's what I use on skew. But I want to show you sometimes, they have certain ways of labeling these things, and I want to make sure you are aware of them. So for B, we're going to do a pair of skew segments. Now remember, skew segments, those are going to be segments that don't touch, yet they're not coplanar. So maybe one's going up and one's going diagonally to the right or left or something. So like I'm going to pick SN first. I'll just pick SN and just go with it. So SN. And then I want to see a line that's not parallel to it, yet still doesn't touch it. You can pick another one other than me. I'll pick PQ. Do you see how they're never going to touch? This one's here, and that one's over here. They're never touching. So I can use that as my skew line segments. So I'm going to go SN and PQ. Yeah, there's more than one right answer, and that's fine. Then we want a pair of perpendicular segments. I'm going to use the perpendicular notation when I do this one as well. But since it's already labeled like right there, and it's really easy to spot, I'm going to use the segments that form that right angle. So that gives me SN again. So I'm going to say SN. And again, we're going to use the perpendicular symbol. That's the perpendicular symbol. And again, we want to see what segment makes this right angle. Well, that's going to be SR. And there we go. Again, there's more than one right answer. As long as your 2 segments form a right angle, you're fine. Alright. And the last one, we got a pair of parallel planes. So again, I can pick either the front and the back plane, the left or the right plane, or the top and bottom plane. I'm going to go ahead and pick the top and bottom plane just because I feel like it. I mean, pick something. So again, we have to label the planes. To label a plane, you label 3 points that lie on the plane. So I'm just, instead of doing all 4, I'm just going to go K, N, M. So plane K, N, M, and plane P, S, R. So those are parallel planes. Again, to label a plane, you just label 3 coplanar points. Okay. So again, you just want to make sure you understand these definitions. If you do, then it shouldn't be hard to label, parallel, skew, perpendicular, or parallel planes. All right. So this one I'll try to go through a little bit quicker. But you still give a second to write the figure out, and then we can obviously go through it quickly. I'm just going to pick sample answers. So again, just make sure that the concepts that you have here are correct. So again, if you need to pause it, go ahead and do that real quick. Okay, so for A, we got a pair of parallel segments. For this one, I'm just going to use BF and EJ. Again, you can use other ones, but BF is parallel to EJ. Again, you don't need the parallel symbol here, you're just labeling them, but I want to make sure you know it. I would use it if it was me. Well, it is me, and I am using it, so anyway. This one, for the next one, skew segments, I'm going to use BF again to get started. And then I have BF. I'll go ahead and use CD up here because they're never going to touch, but they're not on the same plane. So I'll go CD for my second segment. Again, there's more than one right answer. This is just one sample. Okay. Pair of perpendicular segments. This one, since it's labeled again, I'll use that. So I'll say BF is perpendicular to FJ. Again, there's a bunch of them. That's the only one they have labeled, but if you look, all these boxes, this is a box, so we got right angles just about everywhere. You can just label them however you want. And the last one, I'm going to do the left and right faces here as my parallel planes. So again, just use 3 points. I'll do BFC. So BFC and plane DEJ. Again, there's a lot of different ways you can write this. You could not even use these 2 planes. But even if you use those 2 planes, there's different ways you can label them because you have to only pick 3 of the 4 points. So again, you have to make sure you at least understand what the question's asking. As long as you are still labeling, parallel segments, skew segments, perpendicular segments, or parallel planes, if you label differently, it doesn't matter as long as it represents the same thing. Okay, what I mean by like the same type of thing. Don't mind my phone going off there. Okay. So we have some new terms to kind of go over as well. There's a lot of terms in this section. This one we're going to see a lot of, and that's going to be, again, transversals, and then the types of angles that are formed. We actually have a bunch of theorems we'll learn about later that kind of coincide with these. These are not the theorems, however. These are just the definitions of them. So you'll see, again, a corresponding angles postulate, an alternate interior angles theorem, alternate exterior angles theorem. But we can't do the theorems if you don't know what those angles are. So I not recommending, you need to draw this picture. This really sums a lot of these things up, and then you can easily figure out what, where these names come from for all our types of angles. So again, make sure you label, again, exterior, interior, exterior, and these are all our angles, okay? So there are 2 things you need to know. Anything on this side, like if you're on one side, and by the way, guys, as you're doing this, that would be the same as if it's 2, 4, 6, or 8. These are called same side angles. However, if you are going from one side to the other, and you'll see what I mean when you look at the definitions. Okay, these are going to be alternate sides. So when you see the phrase alternate, then that's telling you that the angles are going to be on opposite sides of this line here. If you see same side, that means those angles are going to be on the same side of this line. Now what is that line? Well, that line has a name, and that name is called a transversal. A transversal is a line that intersects two coplanar lines at two different points. So if I have two lines, even if they touch, okay, see these touch, on the transversal, you'll need this picture by the way, we're going to have some problems to go with it. The transversal is going to be this guy right here. It's touching the line, those lines in two different points. Okay, so we're going to have to look for the one that touches it twice. So that's our transversal. So again, look at this picture because the tricky questions are going to look like that. So we need to be able to recognize a transversal. Here, it's this line right here. See how it's touching it twice? It's touching those two other lines. So that's our transversal. It's a line that intersects two coplanar lines. Okay. So anyway, knowing all these phrases, we got corresponding angles. Now corresponding means same side. They lie on the same side. They're in corresponding parts though. You'll see 1 and 5. See how 1 and 5 are both, when you look at the two sets of angles, it's both on the top left, top left. Now some other examples would be angle 2 and angle 6. Again, you can quiz yourself here. We have angle 3 and angle, that would be angle 7. And then you have angle 2 and angle, that'd be angle 6. Okay, so again, it means they're in the same spot. If you have your sets of angles, they're in the same spot on each one. Your alternate interior on alternate sides of your transversal, and they have to be on the interior. So we're only looking at these 4 angles in here. So you'll see we have 3. Well, 6 is on the alternate side. Now again, you can't say it's next to, because that would just be a linear pair. That would be a whole other definition. So they're not linear pairs. Here we're looking at alternate tier, so I have angle 4. That would be an alternate tier to angle 5. So angle 4 and angle 5 would be another set, because they're on alternate sides of the transversal, but they're not next to each other. Again, if they were next to each other, they'd be a linear pair. So they're on the interior of your two coplanar lines, but they're on alternate sides of the transversal. Next up, we've got alternate exterior. So now we're looking out here at these 4 angles, and they gave us not 3 and 5, 1 and 8. So here's 1, here's 8. Notice they're on opposite sides of the transversal. So the other ones, hopefully you can see, would be angle 2 and angle 7. Alright, next up we have same side interior. Again, they have to be in the interior and they have to be on the same side of the transversal. So they gave us 3. Well, notice the other angle is angle 5 because it's on the same side of my transversal. So the other one here, again, you can quiz yourself, would be angle 4 and angle 6. So those are all the angles for each one. So I figured I'd kind of go all in here and explain every single angle that and what their names are. Okay. And again, make sure you have this picture to go along with it. Okay. Example 2. We're going to give an example of each angle pair. So again, notice here that we have this line. I'll call it line L. That's going to be our transversal. You have to recognize that first. And therefore, this portion here is your interior, and these portions out here are going to be your exterior. So if you know your transversal, you know which angles are on alternate sides, which are on the same side, and then you have to then recognize your exterior and your interior. So we got corresponding angles, and we're just giving one example. So I just want you to look at it and try to come up with some. If you understand the concept, you should be fine. But this one I'm going to start with angle 2 for the corresponding angles. So I'm going to figure out what angle is corresponding to angle 2. Well, it means if I'm looking up at this set of angles, that's the top right angle. So I need to come down here and find the top right angle, which is angle 6. So I'm going to go angle 2 and angle 6. Again, it's one of many answers, right? Alright, next, alternate interior. I'll just go pick any interior angle. I'll pick 4. Now, because it's alternate, it has to be on the other side of the transversal. It can't be next to it, or that'd be a linear pair. So that puts me here at 6. So it'd be angle 4 and angle 6. Alright, again, I'm just throwing answers out here. There's multiple. I could have gone 3 and 5. Okay. Alternate exterior, I'm just going to pick 1. Alright, so that's my exterior angle. I need an alternate, which means on the opposite side. Can't be next to. So I'm going to come down here, and that's my other alternate, or my exterior angle that happens to be on the other side. And that's the one I'm going to use. I have angle 1 and angle 7. Again, you cannot use 1 and 2 because those are a linear pair. I could have also gone 2 and 8. Those are alternate exterior as well. And then D, we have same side interior. So I'm going to pick an angle on the interior. I'll pick 3. And it has to be on the same side of the transversal. So on the right hand side, there's only one other interior angle that's on the same side, and that is 6. So angle 3 and angle 6. So those are going to be my same side interior angles. More definitions and apply them. Alright, quick example here. Check it out, example 2. So we can go through these real quick, okay? I'm going to use this as a really fast example. So you can pause this to get it set up if you want to give this a shot first. Alright, first off, we got a transversal. So I'll just do the same thing. It's the same question, I'm just doing it quicker now. And we have our exterior angles here and your interior angles here. So again, exterior over here as well, right? Alright, so once you recognize what's the interior, what's the exterior, and what's the transversal, you can knock these out. So I'm going to start here with angle 1, corresponding angles. I'll go angle 1 and angle 3. They're both on the top left of those sets. Alternate interior, I got angle 2. I'm going to say angle 7 because it's on the alternate side of the transversal, and they're both in the interior. Angle 2 and angle 7. Alternate exterior, I'm going to go with angle 5. I'll start there. So angle 5. And again, I need to be on the other side of the transversal, so on the top of it, and on the exterior, so angle 4. And finally, same side interior. So I need to pick 2 angles on the same side of the transversal that are on the interior. So I can pick 2 and 3 or 6 and 7. I'll say 6 and 7. Again, they are both on the same side of the transversal, which is on the bottom, and they're both on the interior. Right, interior. Okay. So again, hopefully we got these definitions down. That's kind of one of the biggest concepts of Chapter 3, or not Chapter 3, just 3.1 in general. We're going to be applying these definitions throughout this chapter. Okay. Again, another helpful hint here. Just kind of read through it for you before we move on. Determine which line is the transversal for a given angle pair. Locate the line that connects the vertices. So again, when you're looking at determine which line is the transversal, the other little tip I gave you, I'll remind you because we're about to do some tougher ones. Remember I gave you that picture where we had like 2 lines in general? Remember that transversal is the one that also touches them twice. It's the only guy, right? So you got your transversal right here. But again, they're just giving you another hint. Locate the line that connects the vertices. So if you kind of have your 2 lines, you connect the 2 vertices, like these 2 points. But like I said, if you got a line that touches the other lines twice, that's the one that's going to be called our transversal. So you're going to see pictures like this as we go through the final examples here. Okay. So here we have identifying angle pairs of transversals and our crazy figures. So in this case we have 3 types. We got a figure and we have 3 angles, and we want to identify the transversal and classify each angle. Alright, so we're going to go ahead and get started here with A. So angle 1 and 3, is going to be these 2 right here. Alright, so what we need to be able to do is see which, when you look at these angles, which line is intersecting the other line twice. You have to be forming these angles. Well, if you look here, we got this point here, so we got our set of angles, these 4 right here, And we got this set of angles. We have this point where they're intersecting. So if you kind of look, we got M and N. Well, L in this case is going to be our transversal because it's touching both of those lines where those angles are formed. So again, you start by looking at your angles, and again, that's where they say it's connecting the vertices, right? So these are connecting the two vertices of these angles. So it's touching twice. So this L in this first one would be our transversal. So now you look and see what kind of angles we have. Well, this is in the bottom left of these 4 sets of angles, and this is in the bottom left of these 4 sets of angles. If you kind of look, call that like 3 and 4. Actually, I couldn't because that's maybe 5 and 6. But again, these would be the bottom left of those 4. So these are going to be corresponding. Now again, it says identify the transversal, so I'd say, you know, line L in this case. I kind of screwed that up. You probably should have wrote that first. Okay, so you got line L, because that's where it's touching both of those vertices, and they're going to be corresponding angles. Okay, next up we're looking at 2 and 6. Now 2, it's touching here, and 6, it's touching here. So you want to see which line is touching those 2 angles twice, or going through both of them, and that's going to be N. So here we're going to say line N is going to be your transversal. And now let's look at these angles. Well, line N, you got your 2 lines, so these are going to be, you know, the interior. You know, you look at 1 and 6, so they're on the interior, and they're both on the same side, or the bottom left side of that transversal. So this would be same side. Oops, I can really spell, can't I? Okay, same side interior. Again, the reason is they're both on the interior. They're in between those 2 lines, and they're on the same side of the transversal, so therefore same side interior. Okay. Yeah, if you're having a hard time, like, you know, you don't like me erasing all this stuff, you just need to draw that figure 3 times. It doesn't take long, so it's not that big a deal if you want to. Okay. Angle 4 and 6. So we got angle 4, we got angle 6. So let's see, where is this line touching it twice? That's going to be this guy right here, line M. So that's going to be our transversal in the third one. So line M. And now we want to look at these. Okay. So here we got our interior angles, which those aren't. You see how they're on the opposite side or the outside. So these are going to be our exterior angles. And next you want to see, are they on the same side or the opposite side of your transversal? Well, this is on the left side of the transversal, angle 6 is. Angle 4 is on the right side. So these are going to be alternate exterior angles. So alternate exterior, and that's line M for your transversal. So hopefully that kind of makes sense here. Sometimes some of the trickier ones, you just got to see where that line's touching, or you know, which line is touching both those angles. All right, so now it's your turn to do it real quick. We just got one here. Identify the transversal and classify the angle pair of angle 2 and 5. So again, you can try to do this one real quick on your own if you want. It's no big deal. Hopefully you got the hang of it. So you can pause it and do it real fast and then check. Alright, so angle 2 and 5. Again, you see these 2 points. These are the 2 vertices that we have. So we're looking at line N as your transversal. So line N. I'm not doing my cursive L anymore. That's fine. And then we're looking again at angles 2 and 5. Well, they're both on the interior of the 2 coplanar lines that the transversal is going through. And they're also on the same side. So this would just be good old same side interior. So like I said, hopefully you're getting the hang of that. That's about as hard as they'll get, at least for this section. Okay? Alright. So now we got our lesson quiz. Again, make sure you get that pause and you can go through it and fill out the questions. Again, it's got 2 parts, so make sure you save this and this. And it's just definition questions is really all we're doing. And finally, don't forget we got your reflections. So make sure you're filling those out, and good luck.